Topic: measurement and dimension analysis. The question said, state the units and dimension of the following quantity. State the unit and dimension of the following quantity. I, potential energy. I, kinetic energy. I, impulse. IV, momentum. V, pressure. Let's start from immediately. Solution. We said potential energy is the energy due to position where you are or an object is. Potential energy is energy due to what? Position where the object is, which is given as EP equals to mass times acceleration due to gravity because of the height where the person is, times the height where the person is. That is what we said. Potential energy is energy due to position where object is. Mass times acceleration due to gravity times height. Then now, coming over here, what's the unit of mass? Kilogram. What's the unit of what? Acceleration due to gravity? Meter per second square. Then what's the unit of height? Meter. That's what you see here. And I said the unit of mass is kilogram. Unit of acceleration due to gravity is meter per second squared. And the unit of what? H, which is height, is meter. Then multiply this, we have kilogram. I have kilogram over 1 times meter over second square times meter over 1. This times this will give me meter square times kilogram will give me kilogram meter square. 1 times this will give me meter second square times second square again times 1 will give me second square. Look at it again. I have kilogram meter square over second square. Then coming over here, I have kilogram meter square per second square. Look at it. And it equals to, now I cannot get the dimension. Look at the drive unit. The drive unit of what? Potential energy is what? Kilogram per meter square per second square. The dimension of kilogram, which is the mass, is capital M. Dimension of meter is capital L. Dimension of seconds is capital T. Have you seen it now? If I remove this M, put T, put L, it becomes L squared. If I remove this kilogram, I put capital M for the dimension of mass. Dimension of what? Meter is capital R. And when I remove meter, put L, it becomes L squared. When I remove seconds, put capital T, which is the dimension, it becomes minus 2, raised to the power minus 2. And that is what? Dimension. And I said, therefore, the XI unit, of energy is Joule. Remember that XI unit of energy is Joule. The XI unit of work done is also Joule. Then why its derived unit is kilogram meter square per second square. Kilogram meter square per second square. That is its derived unit. Then, and its dimension is capital M, capital L square, capital T raised to the power minus 2. You will not see that I can only get my dimension from my what? Drive unit. You can't get your dimension from what? XI unit. But you get your dimension from the drive unit. Then coming to I say kinetic energy. Let us see. You will see that kinetic energy and the what? Potential energy are the same. Since they are measured in Joule, as well as the dimension, a unit of what? Potential energy is Joule, the unit of kinetic energy is Joule, they have the same dimension and they have the same what? Drive unit. Let's see. Kinetic energy, which is presented as EK. Kinetic energy is energy possessed due to what? Motion. An object moving in motion has a what? Kinetic energy. We said EK equals to what? Half mass times velocity squared. Look at half mass, this is mass, times what? Velocity squared. That means 1/2 means half of the mass times what? Velocity squared. That is the what? The the formula of what? Kinetic what? Energy. Then while we are deriving our drive unit, while we are obtaining our drive unit from this man is a constant. Look at 1/2 is a constant. It doesn't change. 1/2 is a 1/2. So we don't apply constant when we are getting our drive unit. So if a constant is in our formula, while we are trying to get drive unit of that formula, we remove the word constant. Note it now. If a constant is in the word formula you want to get his drive unit, you have to remove the constant because the constant remain constant. 1/2 remain 1/2. Therefore, I have this man now, which is what? Mass. The unit of mass is what? The fundamental unit of mass is what? Kilogram. Then the fundamental unit, the unit of what? The drive unit of what? Velocity is meter per second. If I remove this velocity, put meter per second, it will be raised to power 2. Have you seen it? Because velocity here is raised to power 2. If I remove it now to put this unit, which is what? Meter per second, it will be raised to power what? 2. Have you seen that as I raise it to power 2? Then opening this bracket, these 2 will square m square x. If I open this bracket, these 2 will square m square x because this v has turned into meter per second. Therefore, I can now say this becomes kilogram over 1 times meter squared over second squared. You know what happened? When I open this bracket, this meter will be squared and seconds will be what? Squared. So this square will affect the 2 fraction. Then when I have this there, then this times this will give me what? Kilogram meter square, and this times this will give me second square. And this will give me kilogram meter square per second square. Have you seen it now? From here now I drive my unit, my dimension. I drive my dimension. Dimension of kilogram is capital M. Dimension of meter is capital L. If I remove M and put capital L, it becomes capital L square. Dimension of seconds is capital T. Then if I remove this, become what? T raised to power minus 2. Have you seen the dimension? That this dimension is the same thing as the dimension of what? Potential energy. And I said the SI unit of energy is joule. You remember? The SI unit of kinetic energy is joule. While its drive unit is kilogram meter square per second square. And in its dimension, which we have already got, is capital M, capital L square, capital T raised to power minus what? 2. And that's my what? Answer. You will now see that the dimension of what? Kinetic energy and dimension of potential energy are the same. And the derived unit of potential energy and kinetic energy are the same. You will now see that anything that is measured in joule has the same what? Dimension. Look at it. Work done, energy, and the potential energy. These are energy, work done, and the potential energy. They have the same what? Dimension. As far as their SI unit is what? In joule. They have the same drive unit and what? Dimension. I. That is the question. I. Impulse. We said impulse. Impulse is given as force times what? Time. Impulse is given as what? Force times what? Time. And force is given as what? Mass times acceleration. Impulse is given as what? Force times time. That is the what? The formula of impulse. Force times time. Then force is given as what? Mass times acceleration times the time. Then what's the unit of mass? Kilogram. What's the unit of acceleration? Meter per second square. What's the unit of time? Seconds. Have you seen how we split them now? Then now, this is something as kilogram over 1 times meter per second square times seconds over 1. Then this times this will give me kilogram over here. Kilogram meter square. That's the kilogram meter seconds over second square. Kilogram meter seconds over second square. When you multiply this and this, give me this. Come over here. When I say kilogram meter seconds over second square, these seconds will cancel 1 second here. You know that second square here means seconds times seconds. I think you know. Second square here means seconds times what? Seconds. And over here we have kilogram meter times what? Seconds. These seconds will kill one of the seconds here. Are you following? These seconds will kill one of the seconds here, remaining 1 second. Look at it here. We now have kilogram meter seconds because one have killed one here. Then now, this can be written as kilogram meter per second. What? Raised to power 1. That's per second. That's what we mean by kilogram meter per second. There is another way you can write it. Kilogram meter per second. Look at another way you can write it. Then now my dimension of kilogram is capital M, dimension of meter is capital R, dimension of what? Seconds is capital T. Then if I remove this, I put capital M, remove this, I put capital R, remove X, put capital what? T, I have minus 1. That's its dimension. Then I come over here and say, therefore, the SI unit of impulse is a what? Newton seconds. You will see the SI unit of what? Impulse is what? Newton seconds. Why its derived unit? Why its derived unit is kilogram meter per seconds. Kilogram meter per seconds. And its dimension is capital M, capital R, T raised to power minus 1. That's my answer. We come to number what? IV, which we call momentum. Momentum. We say momentum is mass times what? Velocity. Mass, your mass times your velocity give the momentum which you use to run. Your mass times your velocity give the momentum which you use to run. Therefore, the unit of mass is kilogram. That's fundamental unit of mass. Kilogram. Then unit of velocity is meter per seconds. Have you seen how I started it? Mass, kilogram. Velocity, meter per seconds. Then this will give me kilogram over 1 times meter over seconds. And this will kilogram meter per seconds. Have you seen it now? Kilogram meter per second. This seconds times 1 will give me this. Then this can be written as kilogram meter per second, which is raised to power minus 1. I've explained it in our class, the first class, our class number 1. The first class we did, class 1. I've explained how this thing becomes what? Minus 1. Then now, my dimension. What is the what? Dimension of kilogram, capital M. Dimension of meter, capital L. Dimension of seconds, capital T. We have this. And that becomes the dimension of what? Momentum. Then we say the SI unit of momentum is Newton seconds. While its derived unit is a what? Kilogram meter per seconds. Its derived unit is what? Kilogram meter per seconds. And its dimension is capital M L T raised to power minus 1. You will now see that the unit of impulse and the unit of momentum are the same. Let me prove it for you. You have seen the proof that the unit of what? Impulse and the unit of what? The momentum are the same. The unit of momentum is the same thing as unit of what? Impulse. Since they have the same unit and they have the same unit, since they have the same units, they have the same what? Dimension. Now look at this, how we derive momentum. You remember that we say force. Follow here. Force is equals to mass times what? Acceleration. And what is acceleration? Acceleration is a what? Change in velocity, which means mass into what? Yeah? Velocity, which is V over what? Time. Have you seen it now? Then if you open this bracket, I will have that what? Force is equals to what? Mass, velocity over time. If you now do cross multiplication, this is over 1. Do cross multiplication, I'll have force times time equals to what? mv. Are you following? Then this is called what? Momentum. Why this is called what? Impulse. Force times time is called impulse. And impulse is equals to what? Momentum. And since impulse is equals to what? Momentum, and the unit of impulse, unit of force is Newton. Look at this force. The unit of force is Newton. That's the SI unit of force is Newton. SI unit of second time is what? Seconds. You will now see that impulse is measured in what? Newton seconds. And since impulse is measured in Newton seconds, and the impulse is equals to momentum, therefore the unit of what? Momentum is as well what? Newton seconds. Do you follow now? We say since impulse, watch, Ft is equals to what? Momentum from what I've said now. And you see that unit of force is Newton and the unit of seconds is what? Unit of time is what? Seconds. It implies that the unit of what? Impulse is same thing as the unit of what? Momentum. So if I now say what's the unit of momentum, is Newton seconds. What's the unit of what? Impulse? Newton seconds. And you remember this Newton seconds is SI unit of impulse and is SI unit of what? Momentum. But if we are asked to drive the what? Drive unit of what? Momentum, we say is a kilogram meter per seconds. Kilogram meter per what? Second. That's the what? The drive unit of momentum and drive unit of what? Impulse. And the what? SI unit is a what? Newton seconds. I think you have noted it here now. We have proved that what? Potential energy and kinetic energy have the same what? Drive unit and what? Unit dimension. Also, we have proved that impulse and what? Momentum have the same what? Drive unit and what? And what? Dimension. And they have the same unit. V, pressure. Pressure equals to force over area. That's the definition of pressure. You know that I cannot get drive unit without having a definition of that word substance or that word body. We must define the body we want to get its unit. So I define pressure as force over what? Area. And the F stands for force and A stands for what? Area. And what is force? Force is mass times what? Acceleration over what? Area. Then coming here, this thing I write like this, mass times acceleration divided by what? Area. Have you seen that? This and the same thing as this. Either you write it this way or this way. Then now, mass, kilogram. Acceleration, meter per second. That's the unit. Unit of mass, kilogram. Acceleration, meter per seconds. Divide, look at division. The unit of what? Area is meter squared. Remember that area means length as length. Come over here. Let me get here right. We said area is meter squared. Unit of acceleration, meter per second squared. Unit of mass is kilogram. And this can be written this way as well. Kilogram over 1, are you following me? Kilogram over 1 times meter per second squared divided by meter squared over 1. You follow? Divided by what? Meter squared over 1. Then move. This times this will give me kilogram meter. This times this will give me what? Second squared. Divide by meter squared over 1. Then now, looking at this place, multiplication apply. And I say kilogram meter over what? Second square times this one will come over and this m square will come down. This will remain as they are. Then for me to apply multiplication here, this man will come over, this one come down. Multiplication apply. Watch it here. That's how multiplication appear here. You have seen how multiplication appear here, this man come over. But these people remain as they are. Then I will say this times 1 will give me kilogram meter. This times meter squared, that's second square times meter square will give me second square meter square. Are you get what I'm saying now? Then this thing I write here is same thing as what? Kilogram times meter square. Then this means what? Seconds times meter. You know, meter times meter will give me meter square. Then this meter will cancel one of the meter here. I will leave with what? 1 meter. And I have only kilogram over here. And I say kilogram over what? Second square times meter. Have you seen it? Meter. Then I am coming over here to say this thing I write like this can be written this way. Kilogram per meter per second square. Kilogram up there means kilogram per meter per second square. Are you following? Kilogram per meter per second square. That's how we explain it. Then we will come here and say kilogram per meter per what? Second square. And I have this. What's the dimension of kilogram? Capital M. What's the dimension of meter? Capital L. If I remove meter, put what? Capital L. I will have capital L raised to power minus 1. If I remove what? Seconds and put capital T, which is the dimension, I will have what? T raised to power. T raised to power what? 2 here. I will have T raised to power what? 2 here. Then now, when I have this T raised to power 2 here, that's its dimension. And I said, therefore, the SI unit of pressure, listen, the SI unit of pressure is Newton per meter squared. How did I get it? Look at this. Look at the definition of what? The pressure. force per area. Then what's the unit of force? The unit of force is what? Nothing. What's the unit of area? The unit of area is what? Meter square. And that's why we say the SI unit of what? Pressure is nothing per meter square. Have you seen it? How I get it? This is what? SI unit of what? About pressure. Or you will call it what? Pascal. Another SI unit of pressure is what? Pascal. Pascal. Are you what I'm saying now? The unit of pressure is also what? Pascal, because the Pascal is one that discovers pressure. So we now use his name in the memory of his name. We now use it as a unit. We call it Pascal. Then we need to talk about Pascal triangle when we go to mass 111. We say Pascal is another unit, SI unit of what? Pressure, or nothing per meter square. That's SI unit of what? Pressure. Then derived unit of pressure is what? Derived unit of pressure is what? Kilogram per meter per second square. Derived unit is what? Kilogram per meter per second square. And its dimension is what? Capital M, capital L raised to the power minus 1, and capital T raised to the power minus 2. That is what dimension. Look at it here. I say capital M, capital L raised to the power minus 1, capital T raised to the power minus 2. That is the dimension of what? Pressure. Which you what? Derive here. This kilogram is capital M. This M is what? Capital L. This X is capital T, and that's the what? The what? Dimension of what? Pressure.